1,000 divided by 18. 1,000 is the 1,000 ml divided by the molar mass. Or 1,000, I guess, grams divided by the molar mass. Okay, now let's take a look at some of the properties of equilibriums and Ks. Now, we had this. HNO2, the acid, breaks up into hydrogen ions and NO2 ions. NO2 plus water. This is the base in water. This is the conjugate base of this acid in water. Can pick up a hydrogen ion from water and make, can you see this green writing, Andrew?
Yeah.
Makes HNO2 because it does accept a hydrogen ion plus the hydroxide ion. And we know what the Ks are. What if we add these two reactions together? They're equilibrium reactions, add them together. Anything going to cancel out for us? Yeah, the HNO2 cancels out. Anything else? The NO2 negative cancels out. So we add these two together, what do you get? You get water on the left, making H plus plus OH negative. Now, remember that this first one had a Ka expression, that was K. The second one has a Kb, because it's a base reacting with water. So what do we have here? What is the equilibrium constant for water dissociating? It's Kw. And how do you get Kw, or how do you, when you add two equilibrium reactions together, what do you do with their Ks? Multiply them. So look at this. The Ka of any acid times its Kb always gives you Kw, which we know that number. Kw is always 10 to the negative 14 at 25 degrees Celsius, at least. If the temperature changes, that does throw the equilibrium off some. I don't remember if it's exothermic or endothermic, but it is sensitive to temperature changes. But anyway, we're not going to worry about the temperature at all. So these two things multiplied together always gives you Kw. This is going to be very handy to you because often you'll have some anion in water, and it's going to be basic, and you'll have to know what its K expression or K value is, but the table won't give you the K value for this. It'll give you the Ka value for this, so you'll have to use this to figure out Kb. Just know that this is going to be handy for you. And I would say, write this down in your notes, put a box around it, highlight it or whatever. Daniel?
You forget the strong acid. Is there any way to remember? Is there any way the Ka value would show as the strong acid?
Ka for all these would be infinity. Because the Ka is going to be like this, but that, whatever it starts at, goes to 0. And these start at 0 and go up to whatever that started as. And so it's going to be that times that over 0, which is like infinity.
Is that the same for strong bases?
Did you?
Yes. Yep. Ka for strong acid is infinity, Kb for strong base is infinity. Okay, that's good. One more thing. pH. How do we find pH? Hopefully you remember this from last year. Is this a review? Negative log of the hydrogen concentration. Come on, you've seen this before. Ajay?
Oh,
no, you
yes,
didn't have your
yes.
second semester.
Yes, I have it on my little.
Mark, you've seen this before, right? Just say yes at least, Mark. Help my ego. Mark's the only Chem 1 student I had last year in here. Well, not for the second semester.
Well, I mean, you weren't really a student.
He was present, I guess, for a semester.
Who was your teacher? Bottom right.
You should
do
online
Mr. Dirk Benner. Mr. Dirk Benner's voice.
All right, so anyway, whether you remember it or not, the way that we calculate pH, now we've always used natural log up till now. This is log base 10. I kind of like log base 10 better, but then we just have to get used to the natural log sometimes. The pH is -1 times the log of the hydrogen concentration. All pH does is it gives us a different way of expressing the hydrogen concentration. That's all this is. It gives us the hydrogen concentration with a convenient something close to a number between 0 and 14. Be aware that pOH is sometimes going to be very handy for us also. It's negative log of the hydroxide concentration. And I'm not going to derive how we get this, but just write this down, that 14 minus the pH of a solution gives us pOH. The pH plus the pOH is always equal to 14.
So does 14 equal the log of it, or just the concentration of it? Oh, to get
It's
pH?
the log of it.
What time mark should I cut the video off?
At the end. Keep going.
All right.
Getting tired of this?
No, I'm just saying, like,
I told you gotta tilt it.
You want to have somebody else do it for you?
no, I'm
Okay.
just saying, like, for YouTube, doesn't it have like a maximum for minutes?
Stop complaining, Andrew. If you don't want to do it, then don't do it.
All right.
If I found out, thanks to a tooth, he told me that if I hardwire the iPad into the computer, you can do the whole thing at once.
Really?
Yes, and I tried that and it worked. But it takes about an hour, a full hour, to take a 40 to 45 minute video and put it on there.
For YouTube.
I couldn't
conversion?
believe it. I break it up into 15-minute chunks is all that allows if you're just going wirelessly. And gosh, within 10 minutes you can get the 3 parts on there. But yeah, like an hour, my gosh. It's kind of handy for you, the viewer. If you have it all together, you don't have to go to number 1, number 2, number 3. But
I don't think it's that bad.
One
It's
time,
not a big deal?
One time,
I just have to estimate. You got to slide the bar for parts 2 and 3, and
The
I
worst
just hope
part
that I
is, though,
don't
is,
have
like,
overlap.
when you're in the middle of a sentence and it stops.
And it stops.
yeah.
So you're like writing and you're like,
No, but like one time I couldn't find part 3. I had to like go to like Mr. Hevel's video and then come back to like, part 3.
And then it was there.
Yeah.
I don't know why that happened, but anyway. All right. So, anything else, Andrew?
No.
Did we get a selfie for you too?
What?
Yeah. Who's behind this? There he is, right there. Yeah. Yeah. See, there he is.
Thank you.
Okay. And Merry Christmas to Andrew.
Why did you wait?
Oh man.
All right.
We can cut that out of the video, right?
No.
Okay.
Matt, you got 1 Hanya on your quiz. No, you didn't. Marat got 1 Hanya on
All
your
right.
quiz.
So anyway, let's take a look. We'll just do a couple
You're
of
gonna watch this and be so excited.
pHs.
Yeah.
What's happened? And
It
then
was
we'll quit.
pink.
So, if we have a strong acid, notice this arrow. It's a single direction arrow. It goes from there to there, does not come back the other way. So there really is no equilibrium with a strong acid. It's not really, it does not happen. So, if we had like a 0.1 molar solution of nitric acid or HCl or whatever, when this thing dissolves in water, there's none of it at the end. And all that 0.1 molarity now has become 0.1 molarity of this and 0.1 molar of that. So that for any strong acid, the pH, which is negative log of the hydrogen concentration, well, that's the same thing as whatever the initial concentration of the acid was. Because it goes to completion. Yes?
so is there a possibility you have like 2 hydrogens that come off and then you have like.
Really only, we're going to talk about the diprotic and polyprotic acid. Yeah, we're going to get to that. I'm going to just table that question.
That would miss the pH.
Yes, it would. It would, yeah. Like sulfuric acid, you've got 2 hydrogens that come off that will affect the pH.
You have,
Yeah, we'll talk about that, Jake.
I wish I had
I'm just kidding.
If I have 0.5 molar HNO3 and I want the pH, it's very simple. I just take negative log of 0.5 and I'll have the pH. Because every one of these things breaks up and gives a hydrogen, so that's my concentration of hydrogen. However, if I have 0.5 molarity of HNO2, this is not so easy. because I know that HNO2 is a weak acid, so I don't have 0.5 molarity of hydrogen ions in this solution. But I can figure it out. What do I need in order to figure out what the hydrogen concentration is going to be for this?
Constant.
I need the K value. I need the Ka for this thing because it does come to equilibrium. We're going to have to do an ice table and the whole thing. So, one last slide. Let's do that for
It's pretty.
a weak acid. For a weak acid, now I'm giving you up here a 0.1 molar solution of HOCl. It's a weak acid. How do we know it's weak? It's not one of those. So the Ka value is given to us. I told you in the last chapter too, this chapter we're going to use the 5% rule all the time because we're dealing with things that do not go very far to the right and then they stop. Like in this case, Ka is 10 to the negative 8th power. That's a very weak acid. So we make up an ice table. Our initial concentration is 0.1 molarity. These two are 0, so it is going to go to the right some amount, but then stop. How much does it go to the right? Well, some amount x that we're going to work through the math to do. So that goes down by x, those two go up by x, and so at equilibrium, we have that going down by a little bit, those going up. So that we can determine what x is using the expression for k. It's going to be x squared over 0.1 minus x. It'll be very rare in this chapter that you'll have to use the quadratic formula. Because we're dealing with very small k values, we can neglect that change in x from 0.1. Because it only goes to the right a little tiny bit, x is small enough so that it does not change 0.1 very much, even enough to worry about. So that, is it pretty easy to solve for x this way now? Neglecting that change? It's very easy. Take the k, multiply by 0.1, take the square root of it. And you're going to get something like x equals around 6 times 10 to the negative 5th. When I multiply that by 0.1 and then I take the square root of it, it's around there. So the pH would be negative log of this number, which would be 4 point whatever, 3. I don't know. Okay?
So we only take out the x, we don't take out like 0.01. Or
Yeah, you
0.1.
can't take out the 0.01. There's got to be there. Now remember what the point of that is. The point is because it only goes to the right a tiny little bit, this term is very, very small. So when you take 0.1 and subtract a very, very small number from it, it's still very close to 0.1. Okay? Do check. 5% rule, you want to check when you get the x value, divide it by the original and see if it's less than 5%. You'll laugh at the Zoom dolls because every problem, you know, they're checking and they say assumptions are good or whatever, and it just happens over and over. Anybody have any questions about that? All right, let's be done for the day.
Bye, Brad Cam. We miss you. No, don't do it.
Are we off, Andrew?